In 4.36, we're told that there's a class, 1,500 students took the final exam. The median is 74, the mean is 70, the standard deviation is 10. No one scored above 100, some people scored below 20. So if we were to just kind of sketch this out, we have our mean here at 70, our median at 74. No one can get higher than 100. So we're going to kind of have like a brick wall there. And some people are way over here at the 20s. So it doesn't tell us the shape of the distribution, but exam scores are almost always at least like kind of normally distributed, so I can probably draw something kind of like a normal distribution. Kind of. But it has to stop at 100, so it probably goes something like this, and then kind of normal, and then it probably like peters out like that or something. We don't really know for sure. Didn't tell us. But again, it has to stop at 100. There's a few people down below 20. So then it asks us in part A, is it going to be left skewed, right skewed, or symmetric? When you look at the median and mean, anytime that the median is greater than the mean, that means it was left skew. So because the median, or let's do it the other way, because the mean is lower than the median, we know it must have been pulled down by really low values, probably the people that scored less than 20. Or including those people that scored less than 20. So it must be left skewed. So anytime your median is lower than your mean, that means it was probably going to be left skewed. Part B. Would you expect most students to have scored above or below 70 points? Well, the median is 74, so at least half, well, not at least half, so half of the students have to be above 74 because that's the definition of the median. It divides it in half. So if half of them are greater than 74, that would mean the majority is going to be greater than 70. So these problems are just kind of seeing, can you use some logic. Part C, can we use the probability that a randomly chosen student scored above 75 using the normal distribution? Well, this says a student. That means n would only equal 1. That is smaller than n equals 30, so we shouldn't use the normal distribution to find probabilities, unless we are actually told the actual data looks normal. And like I said, test scores usually are, but not always. It does depend on the teacher, so we don't have a guarantee, so we better not do it. Part D says, let's find the probability that an average score is greater than 75 for a sample size of n equals 40. Well, this is bigger than n of 30, so we are good to use the normal distribution to find probabilities. So again, because we're looking for the sample mean and we know we have a big sample size, we know that our possibilities for all of our possible sample means, that sampling distribution, will be normal. But we do have to find the new mean and the new standard deviation. So the new mean for the sample means is actually equal to the mean of the original population, which in this case was 70. So our mean is 70. And you have to find the new standard deviation, which is always equal to your standard deviation of the original population over the square root of n. So the standard deviation for this population they told us was 10, square root of 40. 10 divided by square root of 40 is 1.581. So we're going to use our calculators with a normal CDF function. We're going to use a mean of 70 and a standard deviation of 1.581, since those are our new means and new standard deviations we found for the sample means. And then you need a lower bound and an upper bound to put it in your calculator, because we're finding the probability that x is greater than 75. So we say, okay, here's 75, and we want to find the area from that all the way to the right because it's greater than. So we don't really have a true upper bound, so we'll just put in our calculator some ridiculously big number like a billion or something and see what we get. So our lower bound will be 75, our upper bound will be some big number with lots and lots of zeros. And so my answer will be the probability that we get a sample mean greater than 75. I put it in my calculator and I get 0.000781. So a pretty small value.